Hello. Okay, good morning, students. I welcome you all on a Monday morning for the first lecture. I'll be starting with basic electronics lecture in some time. Before that, today we have one of you. I'll just unmute Adil Saudagar. Can you listen to my voice clearly?
Yes, sir.
I have just unmuted him just to confirm that my voice is perfect, loud and clear. You can listen to me, right?
Yes, sir. I can.
Okay. Thank you. Okay, students. I welcome you all on behalf of Tadomal Chand Engineering College. I'll be taking PWE lecture, and before that, I need to inform you that today we have sent you invite on Zoom. But normally, our software for college on which we take online classes, even tests, assignments, and everything that is related to your curriculum happens on Microsoft Teams. So maybe by tomorrow or today evening, we'll send you all a username and password, the first time password with which you have to log into Microsoft Teams. Now I'll tell you what to do. Briefly, I'll show you some screens for Teams. What you have to do is on your laptop or desktop that you will be using and on your mobile, you download Microsoft Teams. If you have an iPhone, if you have an Android phone, Microsoft Teams is available as a software. So I'll be showing you some screens of Microsoft Teams, how to log in for the first time, and everything, and then I'll be starting with my lecture. So I'll just share my screen. So I was saying that whether it is on Android or whether it is on iPhone, you download Microsoft Teams on your mobile. Secondly, even on your laptop, on desktop, through the browser, through the browser, one of your connection is a host connection. You can go to Microsoft Teams and download it and keep it on your machine. We'll be sending you a username and password. We'll be sending you a username and password for Microsoft Teams. Log in on Microsoft Teams. It will be basically your name, some numericals, and after that, I'll just show you. I'll go to the browser and type Microsoft Teams. When I type Microsoft Teams, okay, you get an option here which says download Microsoft Teams. My machine already has Microsoft Teams. So you can download now, and the username and password that we send you, you sign in. The moment you sign in, please make a note. It will ask you to register your mobile number and email. The moment you register your mobile number, you can choose one of the two options. It will send you an OTP on your mobile number. Type that OTP, okay? Change your password and then log in and remember the password. Write down your username and password somewhere. The OTP and the mobile number that you have registered, the OTP will come for only one time. The mobile number that you have registered will be used in case you forget your password. So I repeat, go to Microsoft Teams, you download the software, log into your account using the username and the password that we have provided you. The moment you log in, it will ask you for your mobile number. You enter the mobile number, it will ask you to send OTP or call. You say send OTP and OTP will come to you and it will prompt you to change your password. It will prompt you to change your password. So change your password, keep the password written somewhere, keep it handy, and then you will be logged on to Microsoft Teams, right? Now, the moment you log on to the Teams, okay, make sure you use your username and password and log in using your mobile also. So now on your desktop or your laptop, you are logged into Microsoft Teams, and even on your mobile, you are logged into your Microsoft Teams account. Now Teams has following menu as you can see on the left hand side. The format is slightly different on mobile, but the basic structure is the same. It will give you option of Teams, files, calls, calendar, assignments, and so on. You will understand everything one by one, but today I'll be only talking about teams. So we will be adding you in a team of first year. As you can see on my screen, okay, I have lot of teams, okay, some practicals that I take, okay, some exams that I have taken, some lectures that I have taken, but you will have currently only one team, and that will be your FE team, and you will have a calendar in it. The calendar will always have the timing of the lecture. So for example, every Tuesday at 11 a.m. I used to have a lecture for fifth semester. So you can see I have here a lecture from 11 a.m. to 12 p.m. Same calendar will appear on your mobile as well as on your laptop. Now, normally your laptop will be on, but your mobile will always be handy. So you can always receive notifications on your mobile, or you can check on your mobile calendar for Teams as to how and at what time you have lectures for first year. So again, I'm unmuting Adil Saudagar. Adil Saudagar, did you understand what I said?
Yes, sir. I did.
So just I'm asking two, three people that was I clear? Anushka, I'm unmuting you. You understood what I just said? Anushka, Abhishek Kumar,
Yes, sir, I understand.
you understood. So I repeat, we'll be sending you username and password of team. By that time, you make sure that you have downloaded team on your laptop as well as on your mobile. And from tomorrow, or preferably from tomorrow or maximum Wednesday, we'll start taking all your lectures on Teams. You'll get notification about which lecture is there at what time in your calendar. You'll be automatically added to the first year team. Today, because we have not given you username and ID, and we wanted to interact with you as fast as possible, we have used this Zoom platform for interacting. Now, Microsoft Teams, remember, that will be the only platform mostly used by us in taking online lectures. Practicals temporarily also will be online as and when they start. Uh, but later on, you'll be coming to the college as and when everything gets fine. And Teams will always use for all your lectures, even assignment submission, even your exams that we will be taking. Everything currently is happening on Teams. So make sure you have it on your laptop as well as on your mobile. Okay, so I'll this much was the introduction for Teams. As and when you have any doubts regarding Teams, you can interact with me. I am joint FE coordinator also. So any doubt you have, I'll be sharing my number later on with you all, and you all can communicate with me. If you have any problem with logging on to Teams account, you can always mail back to us on the mail that will be received to you. We'll be helping you regarding the same. Okay. So basically, for your first year engineering course, we have 5 subjects for which you have to do theory, and you have practicals also. The subjects for which you have theory are engineering mathematics, BEE, which is basic electrical engineering, applied mathematics, as I have already said. Uh, Maths is there for several semesters, so right now it will be called as Maths 1 because you will be in the semester 1. BEE, mechanics, physics, chemistry. Along with that, you also have some workshop and practicals for every subject. As and when we'll be starting that, we'll tell you in some time. Currently, what we'll do is for every day for 2 to 3 hours, we'll be engaging basic electrical engineering, mathematics, and mechanics lectures. Again, as I told you, the detailed timetable will follow. But for everyday schedule, the moment you download Teams on the calendar, it will be automatically updated every time when we have a lecture for you. Okay. So what I'll be doing is I'll be starting with BEE lectures. I teach BEE for first year. So BEE lectures I'll start. Now, some of you must have taken vocational in your 11th and 12th. In that vocational, some of you might have taken electronics, some might have taken computers, and some might have not taken vocational at all. Now, for all of you, some might not like electronics, some might not know anything about electronics. Very good, fine. We are there here to imbibe everything related to the subject that is required. Now, today is the first day, so I would not need any calculator. But even a normal calculator from tomorrow, whenever I take BEE lectures, actually for engineering, we will need a scientific calculator. We'll inform you which scientific calculator to buy. So I'll be starting with BEE lectures today only, and don't worry whether or not you like electronics or no, or whether you know or know electronics or no. We are there to make sure that each one of you is well versed with the subject and expert. Okay, so BEE, the full form is Basic Electrical Engineering, and it basically deals with electronics fundamentals. So I'll start with the first chapter that is there for electronics, BEE that is, and it is about DC networks. In between, I'll unmute some people, so because I would like to know how much I'm making sense, and so I request you that whenever I unmute you and ask you, so please respond. Yeah, you all must be aware because it's there on my screen. My name is Mukesh Israni. I am from IT department, and I'll be taking your BEE lectures. Adil, I have unmuted you.
Yes, sir.
Others can, some of you can sparingly put in your chat section. Is Ohm's law the basic from where I can start the subject?
Um, yes, I know also.
Everybody is aware with Ohm's law. I just
Yes,
unmuted Adil because he's the first on the list. Later on, I'll keep unmuting other people also. So I see. Yes, fine, fine, fine. That's it. That's it. That's it. Okay, okay. We'll start. So Ohm's law is the basic from where I'll start BEE, and we all know the formula for Ohm's law. Okay, that somebody, if you want, you can put in chat. The potential difference applied across two ends of the conductor is directly proportional to the current flowing through the conductor, and all physical conditions remain the same. Yes, very nice. V equals to IR. A lot of people have written. I am very happy. I am very happy. Good, good, nice. So the basics of electronics will be that we'll be dealing with voltage source, a current source, and a resistance. Okay, I'll be again sharing my screen. So you can see this is the symbol for a DC voltage source. This will be a symbol when we use multiple cells. Okay, AC voltage source will take in some time. This is how a resistance looks like. That is what we'll be using as a symbol when you are in the lab. We'll actually show you the resistance. And current source, instead of having a V written inside, will have an arrow. That arrow will indicate the direction of the current source, which side the current is going. So when we talk about DC networks, when we talk about DC networks, okay, we'll basically be dealing with voltage sources, current sources, and resistances. So we all know Ohm's law, V equals to IR. We'll now move on to resistances in series and parallel. When several resistances are connected in series and parallel, right? We will need to sum those resistance and find its equivalent. So the equivalent resistance will be given by the summation of all the resistances that are connected in series, right? So if I have three resistances connected in series and I want to find what is the equivalent value, then the value will be given by the summation of the resistances. So resistances in series are given by, if I have three, so the equivalent resistance will be given by R1 plus R2 plus R3. This is the total resistance given. Now, if I have resistances in parallel, then the equivalent resistance is given by, if I talk about two resistances, then it will be R1 into R2 upon R1 plus R2. This is how we write. But if I have several, more than two, then we'll say that the equivalent resistance, the reciprocal of the equivalent resistance, is given by the summation of reciprocal of individual resistances. So it will be 1 upon R equivalent equal to 1 upon R1 plus 1 upon R2 plus 1 upon R2, right? So I'll also write it. The equivalent resistance will be given as 1 upon resistance of equivalent resistance will be 1 upon R1 plus 1 upon R2 and plus 1 upon R3, right? So I think you all have a book and a pen with you, as I told you. What you can now do is I'll put in some resistances in series and parallel and ask you to find the equivalent value. So let's say I have a very simple sum like this. Please note it down. The question will be find equivalent resistance across points AB, and I'll keep the values as 10 ohm, 10 ohm, 5 ohm and 5, right? So can someone tell me? Everybody has very nice. I'm getting the answers as 15, everyone. Anybody has a doubt can raise a hand and I'll unmute you and explain it to you. The two resistances of 10 ohm that we have, these two are said to be in parallel. So I'll get a single equivalent resistance of 5 ohm here. So one thing which I need to tell you and you need to remember is that when two equal resistances are in parallel, I repeat, when two equal resistances are in parallel, their answer would normally or always be equal to half. So 10 ohm, 10 ohm, they are both equal. So if I ask you what is the equivalent, the answer should be 5. 20 ohm, 20 ohm, if they are in parallel, and I ask you what is its equivalent, the answer will be 10. So the equivalent resistance here will be 5. And you sum each 5 ohm, 5 ohm, 5 ohm, the answer will be 15 ohm. Anybody who's not getting 15 ohm can tell me. Siddhi, the answer should be 15. Siddhi, I have unmuted you. Yes, Siddhi, can you listen to me, Siddhi Chitnis? Siddhi, the answer is 15 and not 10. Are you clear now or should I solve your doubt? Okay, mic is not working, but did you understand how the answer is 15? The two resistances of 10 ohm, 10 ohm are in parallel. Okay, very nice. The answer will be 15 and then all three are in series, right? So the total answer will be 15 ohm. We'll do one more sum. I'll just erase this. The question remains the same. Okay, Siddhi, I'm sorry you were asking to, you were telling me about 2020 parallel. The answer was 10. I am extremely sorry. I did not understand that. Fine. So I'll give you another sum. Again, the question will be find equivalent resistance across points AB. The sum looks like this. I'll change the color of the pen. So again, the question will be find equivalent resistance across points AB. This is 5 ohm, 5 ohm, and this is 10 ohm and 10 ohm. So can you tell me the equivalent resistance across points AB? So here again, I'll tell you another idea later on, but these two, they are in series. Again, these two, they are in series. So this becomes 15 and 15. Again, two equal value of resistances are in parallel. So the answer will be half. So the answer is 7.5. Anybody else can tell me any other idea or how did you solve it? 7.5 is the perfect answer. Anybody, if you have a doubt how 7.5 is the answer, can raise your hand. Okay, I'll change the sum slightly. I'll put a line. Okay. Now can you tell me the value of the equivalent resistance between points AB? How much will be the answer? This one? No, it's not the same. See now, this is my point A, and instead of drawing the resistance tilted, can I draw it like this? This will be 10, this will be 5. Again, this will be 5 and this will be 10. And this is point B. Can everyone tell me, are both the diagrams same? Are both the diagrams same? Yes, some people are putting the answers, but right now my question is, all are both the diagrams same? Only thing is there the resistance were slightly tilted. Here the resistances are straight. I've made them straight. Are both the diagrams same? Yes, both the diagrams are same. Both the diagrams are same. Only thing is, instead of keeping A as a single point here, I have drawn it as a line here. Then instead of drawing this 10 ohm tilted, I have made it straight. Again making this tilted, I have made it straight. This is a connection. Okay, so we have shown it as a straight line. Here also a straight line and connected. So this thing is shown like this here, and this is 510. Both the diagrams are exactly same, and you can see now that this 10 and this 5 are in parallel. Am I right? And this 5 and this 10 are again in parallel. So 10 and 5, if you want to know how much will be the answer, I have already given you a short formula, R1 into R2 upon R1 plus R2. So it will be 10 into 5, which is 50 upon 15. And it will be in series with 50 upon 15 again, right? So the answer will be how much? 100 by 15, which is 20 by 3. Everybody has put the answer as 20 by 3. You can divide it and also put. Some people have given me the final answer. Very nice. Okay. Anyone not clear with this sum can raise your hand and ask me. I can explain it. Anyone not clear with this sum yet? Okay, 20 by 3 is perfect. Fine. Very nice, students. So we'll do one more sum for resistance in series, parallel, and finding the equivalent. Now I'll give you one more diagram, and the question is still same. Find equivalent resistance between points A and B. This is point A, this is point B, this is 10, this is 5. The question is still the same. Find equivalent resistance across AB, and you can see uh, this that you have seen here is a jump which shows that these 2 points are not connected. Fine. So I have a 10 ohm resistance, 10 ohm resistance, 5 ohm resistance, 5 ohm resistance, and a wire connecting these 2 points. Can you tell me the answer for this? Yes, I see some people are putting answers in chat. Initially, some people gave me the answer as 7.5. Somebody gave me 20 by 3. The best thing that I'll do for this sum is, people, you can stop typing in chat. I'll just redraw this diagram. Can I name this point as C? And remember, this full line is the same. So even this is point C. What I'll do is I'll redraw this diagram. I'll call this as point A. This is point B. From A to C, I have a 10 ohm resistance. So you can see this. This is my 10 ohm resistance. So I have made this. Then again A to C, I have a 5 ohm resistance. So I'll make 5 on this side, and this full line I'll call point C. Is that okay? Then from B, you can see, so I have made these two things. Now again from B, you can see I have a 10 ohm resistance going to C and a 5 ohm resistance going to C. So from B to C, I'll make a 5 ohm resistance. And again from B to C, I'll make a 10 ohm resistance. You can see this. And I have this line in between. Tell me, students, is it the same sum we just now did? Is the sum exactly the same sum that we just now did? And what is the answer we got for the sum? 10 and 5 were in parallel. 10 and 5 were in parallel, and the whole thing was in series. So this sum and the previous sum that we did, only rearrangement gave me this new figure, and my answer is still 20 by 3, right? So whenever you get a sum like this, which I just now gave you, rearrange the diagram, and you cannot understand, what you can do is redraw the diagram and try to make it a little simplified, and then understand how to do the sum. Fine. Can I give you one more sum? And once we are perfect, we can move ahead. One more thing, student, please give me a feedback. Am I okay, slow, fast, not audible, language not clear, anything you would like to change? My diagram is not clear, my writing is not good, anything that, because see, we are not in front of each other, we are on an online platform. So I need to understand that y'all can understand what I'm saying. All good, sir. Thank you very much. Anything that you need to uh, need me to change, please put it. If you want me to go a little slow, my language is not clear, you want me to talk a little fast, okay, I am going from exactly from basics, so that everybody who's there. One more thing, we are a group of 100 people here. Anybody who's not understanding any sum, okay, we don't have to feel shy. You can ask me, or you can send me a personal chat. I will not name you here, and I will specifically teach you separately. Fine. Anything that you don't understand and you feel that I can't ask a doubt on such a large public platform, you can send me a personal chat, and I will make sure that I make that point clear to you. Okay. Thank you. We'll move on to the next sum. Yes, sir. So can you tell me the answer? A lot of people have put the answer. 22.5. Again, you can see these two. They are in parallel. The answer will be 5 ohm. This, and this, they are in series. The answer will be 25 ohm. Again 25 ohm, and this 25 ohm will be in parallel. So the answer here will be 12.5. And this 12.5 and this 10 ohm are in series. The answer will be 22.5. Very nice. A lot of people have answered it correctly. Can we move on? Now please tell me the answer to this. Can this be solved? Okay. A lot of people have put the answer as 7.5. A lot of people have put the answer as 22.5. Can anyone tell me how? You can raise your hand and I'll unmute you. Can anyone tell me how? Yes. Somebody put here Wheatstone bridge principle. The opposite arms that I have kept here are equal. And whenever the opposite arms are equal, what will happen? There will be no current in the center branch. So this is redundant, can be removed. So the diagram will become like, okay, fine. We'll change it. This is 10 ohm. This is 15 ohm. This is 20 ohm. This is 10 ohm. And this is 5. Now, can anybody solve it? Can anybody solve this? See, now This 10 and this 15 can't be in parallel because this 20 ohm has come in between, right? So I'll tell you, is there anything series parallel in the figure? Students, are you solving it? Advait got the answer as 60 by 11. Can you tell me how, Advait? Just type what logic did you use? The three branches are in parallel. Which three branches are in parallel? Uh, Students, I have not taught you Kirchhoff's law, nothing. So no Kirchhoff's law, nothing. We have to use the fundamentals of series parallel. Fine. I'll just tell you, nothing is in series parallel here. And as somebody said here, I think Siddhi, you have to use star to delta and delta to star. So I'll erase the sum for the time being. I think you all have this sum. It is 10, 15, 20, 10, 5. I have one whiteboard, so I'll have to remember the sum. I'll first teach you what is star delta. Then we'll solve this sum by star delta and let's see what is the answer. So I'll just erase this. Now, whenever three resistances are like this, they are said to be in a delta. So this is called as a delta connection. And whenever three resistances are like this, or even like this, slightly tilted, this is called as star or T network. Another name for delta connection is a pi connection, because we can even show these resistances like this and it looks like a symbol pi. So on the left hand side, the network that I've shown you is called as a delta or a pi connection. And on the right hand side, the network that I've shown you is a T, letter T. Okay, this looks like a letter T or a star. Fine. Now, when in the diagram that I have I showed you, this one, you can see that neither of these two resistances or these two resistances or these two are in series or in parallel. But what we can see is that this one forms a delta or the lower one forms a delta. We don't need to do both as deltas, but the upper one is a delta. And if I convert a delta to a star, then what I can do is I can convert these three resistance or the lower three resistances into three resistances like this. I'll have a new diagram which looks like this. And the original one remains like this. So this is B, this is 10 ohm, this is 15 ohm, and these three resistances are new, and I have my upper point A. Now, if you can see this diagram, can everyone be sure that these two are in series? We'll find out the value of this one, but are these two in series? Can I get a yes or a no? Again, are these two in series? Then whatever is the answer from these two and these two, both will be in parallel, and then whatever is the answer here and the upper one will become in series. Is that okay? So in sums like this, where we don't have any resistance in series or parallel to go ahead, what we need to do is convert one of the delta to star, or in some other diagrams convert one of the star to delta and solve. Fine. So we'll see what is the formula for conversion from delta to star. So I am drawing the delta network again. So this is my delta network RA, RB, and RC. And inside that, I'll draw another network, which will be a star network, and we'll name them as R1, R2, R3. Is that okay? Now, sometimes we'll need to convert a delta network to star, or sometimes we'll need to convert a star network to delta. So we'll see the formulas for both. Now let's say that I know RA, RB, RC, and I want to find out the values of R1, R2, and R3. So I need to know. Is that okay? So what will be the formula for R1? Can you tell me what are the two adjoining resistances to R1? R1 को कौन से दो रेजिस्टेंस ने आजू बाजू से रखा है? RA and RB. R1, what are the two adjoining resistances? So for R1, I'll say it is RA into RB, and denominator for all three will be RA plus RB plus RC. That is how you convert a given delta network to a star network. Right? So the formula for R1 will be what? The two adjoining resistances RA into RB upon sum of all, that is RA plus RB plus RC. What about R2? What about R2? What will be the formula for R2? R2 will be RB into RC upon RA plus RB plus RC. Perfect. Very nice, students. I like the way you are putting the answers in the chat. Somebody, Hina wrote RB into RC upon some. Somebody actually typed. Very nice. Very nice. And what about R3? R3 will be RA into RC upon RA plus RB plus RC. Is that okay? Students, please note it down. So these formulas that I gave you were for conversion from delta network to star network. Is that okay? So anytime I need to convert a delta network to a star network, what to do? Bazu ka resistance, the adjoining two resistances of the delta network you multiply upon sum of all. Is that okay? Have you noted down? Can I move to the reverse? That when I need to convert star to delta? So now I need to convert a star network to a delta. So again, I'll draw the diagram. This is my a delta network, and this is my star. I've kept in the naming same. So now what to say? That I know R1, R2, R3, and I need to get RA, RB, RC. In this case, I'll say that I am converting a star network to a delta network. So let's say I want to find how much is RA. Now, just check. RA, what is the resistance opposite to it? Can I say R2? आर ए के सामने स्टार का रेजिस्टेंस कौन सा है? R2। आर बी के सामने कौन सा है? R3। वेरी नाइस। एंड आर सी के सामने कौन सा है? R1। So I'll give you the formulas for all three. Just check. RB equal to RC equal to. So whatever is the resistance in front of RA, you keep that in the denominator. So for RA it will be R2. For RB it will be what? R3. And for RC it will be what? R1. And in the numerator, what you have to do is you have to do RA into RB plus RB into RC plus RC. I'm sorry. I'm sorry. I'm sorry. It will be R1 into R2 plus R2 into R3 plus R3 into R1. So what do we need to do? Multiply this with this, multiply this with this, multiply this with this. Fine. So you have to multiply R1 with R2, R2 with R3, and R3 with R1, and sum all. So numerator everywhere is same. Now somewhere you'll also see this answer as RA equal to R1 plus R3 plus R3 R1 upon R2. क्या किया है? We have divided by R2, so the first one becomes R1, the second one becomes R3, the third one becomes R3 R1 by R2. But I like this one better. Why? Because you don't have to learn the formula. What you have to do? Just multiply R1 with R2, then R2 with R3, then R3 with R1. Keep it in the numerator everywhere. And for RA, take the सामने वाला resistance which is R2. For RP, take the सामने वाला resistance R3. And for RC, take the सामने वाला resistance which is R1. Am I clear here? One or two sums and then go there. Let's say I give you something like this. This is 10 ohm, this is 20 ohm, and this is 30 ohm. I need to convert this into star. So convert a delta to star. So the star one will look like this. Can someone tell me the answer? Let's say we call them as R1, R2, and R3. Now, if you have written, that's fine. Remember what did I tell you for R1? बाजू का दो resistance multiply कर दो and upon sum of all. So what will be R1 and R2 and R3? R1 will be 200 upon 60. Very nice. 20 into 10. Yes. So 20 by 60. 20 by 6. I'm sorry. What about R2? R2 will be 20 into 30. That is 600 upon 60. That's 10 ohm. And the third one will be 30 into 10. That is how much? 300 divided by 60. So 5 ohm. Perfect. Everybody understood? Can we go reverse now? We'll take the same answer. We'll take the same sum 20 by 6. Yeah, chalo, we'll take a new sum. Then we'll come to a different. Let's say I give you these three. This is 10 ohm. This is 20 ohm. And this is 30 ohm. And I ask you to get me the delta. So now I need to know what is RA, RB, and RC. RA, RB, and RC. I need the value of these things. I'm sorry, I was muted. So we are clear with star delta, right? I'll just show you again because I was muted. So somebody. So this is the answer. Everyone, is it clear how to get this? Okay. So to get RA, RB, RC, the numerator will be same everywhere. You'll do 10 into 20, that's 200, 20 into 30, that's 600, and 30 into 10, that's 300. You add them all, your answer will be 1100. Keep that in the numerator everywhere. For RA, you'll divide it by 20. For RB, you'll divide it by 30. For RC, you'll divide it by 10. And your answers will be RA 55, RB 36.67, and RC 110 ohm. Am I clear here? So now let's solve the sum that I had given you initially. Now tell me the answer to this. I'll give you a minute. Please solve it. You can convert the upper delta to a star, or you can convert the lower delta to a star. That's your choice. Do it and tell me the answer. So your new diagram will look like this. Can you tell me the value of this resistance? This one. It will be 10 into 15 divided by 20 plus 10 plus 15. That's 45. So the resistance that I've marked, the value will be how much? The one that I've marked. I need to know the value of the resistance that I have marked, this one. It will be 10 into 15. That's 150 divided by 45. So the answer is 3.33. Very nice, students. For this one, how much will be the value? It will be 20 into 15 divided by 45. So you all have written 6.67. Very nice. And for this one, the answer will be 4.44. That's good. So what will be my new diagram? The new diagram will be this resistance remains 3.33. These two are in series. So the answer will be 14.44. This will be 11.67, and I'll have my ND. Now these two are in parallel. What will be the answer for that? The answer for these two is 6.45. Very nice. And then the remaining are in parallel, sorry, series. So my final answer for RAB will be 9.78. Never forget to put the unit. That's all. So that's your answer. Final answer is 9.78. Very nice, students. Anybody who has not understood, not got the answer, can personal chat me, a personal message me on the chat, and then we can uh, have a personalized discussion on that. Anybody who's not understood, can I give you another sum? Can I give you another sum? Okay, let's solve it. Solve. Okay, I'll give you some time. Please solve. Okay, a lot of you all have solved it also. 18.66. What you could, people, if you have not got, what you can also do here is redraw the diagram. We can call this point as C and D. I'll draw it in small here, and then I'll show it to you on a new page. You can start A here and B here and draw C and D here. So सबसे पहले between CD I'll make a 20 ohm resistance. So I've done this. Now between A and C I have a 10 ohm resistance, so I'm making that. Between A and D I have a 5 ohm resistance, so I'm making that. Then again between B and C I have a 10 ohm resistance, and then between B and D I have a 30 ohm resistance. So all the values might not be the same, but it's the same sum that I gave you. You need to convert one of the delta to star and solve it. So people, those who not got, start doing it. How much is the answer? 12.05 final. I'm giving you 2 minutes. Just check. Again, anybody who's not got the answer. Yes, you're getting a problem in getting the diagram. एक minute. Students, give me one or 2 minutes. Students, I'll give you a new sum and tell me the answer to that. Okay, it will have everything: series, parallel, star, delta, everything. Answer to the previous sum is 12.05 or 12.06. That's fine. Now do this sum and tell me the answer to this. Hey students, I have just got disconnected from one of my machines. I teach from a tablet and I'm there on the screen. So I'll get back to you in a second. Just connecting. Yes, I'm back. Okay. So can you solve the sum? Let me solve the sum. So you could have converted this delta to star, or you could have converted this delta to star. दोनों करने का जरूरत नहीं है. Anyone you could have converted. So tell me the answer. Everyone is getting 16.01 ohm. Anybody has any doubt? Right. So students, now we'll start with the derivation of conversion of delta to star and star to delta, and keep on doing these sums in the next time when I take your lecture again. We will not complete the derivation today, but we'll at least start the initial part where I'll make you draw the diagrams and write down the formulas, and then we'll do the derivation next time. 15.97, 16 ohm, fine. Somebody did not get the answer, can put it on personal chat. Do I need to explain? Do I need to explain this? Just say yes, I'll explain. Okay. I'll explain the fact. Oh, so which one you all have converted? The green one or the red one? I had marked this one in red, the green one. So I'll do it using the green one. Fine, fine. So my new diagram will look like this. This is my A, and the remaining part of the diagram will remain the same. So this is 5. I have reached the B point. This is 15 ohm. This is 15 ohm. Please note, students, that you are converting the 5 ohm, 10 ohm, and 20 ohm into star. So in the new diagram, these three resistances not come. And what I am doing is I am drawing the OA a little straight. Okay. So this is my A. Now tell me what will be the value of this one, this resistance. Yes, sir. What if we convert 20, 15, 5 star to delta? I'll even do that. Give me, let me finish this. I'll even do that. Okay. So what will be the answer to this? It will be 50 by how much? 1.43, right? How much will be this? How much will be this one? Will it be 200 divided by 35? And it turns out to be 5.71. And what about the third one? It will be 20 into 5. So I'll call it 2.86. Students, I have a habit. If the third decimal point is more than 5, I add 1 to the previous one. So instead of 2.85, I will write it as 2.86. Now, how are these two? Series? How are these two? Series? And then they'll be in parallel, then everything will be in series. Can you tell me the answer? It will be 15 plus 5.71 will be 20.71. Then 15 and 2.86 will be 17.86. These two will be in parallel. And then finally, I'll get a diagram like this. This will be 5, this will be 1.43, and this will be 9.59. So my RAB will be 9.59 plus 1.43 plus I'm getting the answer as 16.02. So 16 ohm, 16.01, 15.99, everything is fine. Understood? Can I remove it and do this one? If you want, I'll convert this one and show you. So let's say students, I'll have these three resistances. The remaining I am drawing as it is. What will be the value of this one? It will be 20 into 15 divided by 15 plus 15 plus 20 is 50. So I think this is 6 ohm. This one will be same 15 into 20. So this also turns out to be 6 ohm. And this one is 4.5. Now these two are in series, these two are in series, then they are in parallel, and then everything is in series. If you find out here, your answer will be 16.02 ohm. Same answer. It has to be same. So understood, students, whether you convert that delta to star or this delta to star, your answer is going to be the same. Uh, Somebody has sent me a message. Anybody has any doubt can raise your hand. I'll not do any more sums today. I'll stop here. Students, I'll unmute you in some time. Which textbooks? Right now, no need. Just refer to what I teach you. Just refer to my notes that I give you. In fact, we'll be sending you a big book which will have all the sums on BEE. Right now, don't spend any money on buying any textbook. We are there. We'll give you all the notes. We'll give you all the sums that you need to practice with the answers. So, do we need to copy the derivation? We'll do the derivation. And if you want, you can take a screenshot. If you do it with me, if you do it along, it will be the best. We are not doing the derivation today. I'll start it afresh, maybe tomorrow when I take a lecture. Yes, Siddhant has raised his hand. Yes, Siddhant, I have unmuted you.
Sir, the question whose answer was 9.78.
I'll just move my slides and you tell me where I need to stop. This one you're saying?
Yeah, sir. Yeah, this one.
Yes, tell me.
Sir, I'm getting it 6.67.
Okay, this was the starting point, right? Where I'm putting a red dot.
Yes, sir.
We converted the upper delta to star. Was that fine with you? So this
Sir,
step
I
is
copied
okay?
the question wrong, sir. Sorry.
Huh?
Yes, sir. I copied the question wrong, sir. Sorry.
I thank you for asking the doubt on such a big platform in openly. Thank you.
Welcome.
Yeah. Hemal has asked me when will we get Teams ID and password. We'll try to do it as fast as possible. Maybe today, maybe tomorrow. But if we don't do it today, I'll try to arrange one more lecture on Zoom tomorrow only. Just make sure that you check your email, whether it is for the Zoom link again tomorrow or whether it is for Teams password. Please check it. The moment you get your Teams password, I told you. If you want, I'll repeat. Log on to Teams and make sure you do it on your mobile also, because your laptop is not permanently on. Any lecture or any notification that we want to send regarding academics we'll always post on the Teams, so your calendar will get automatically updated. When will offline lecture start? Please don't ask me such questions because I don't know. As and when the government does the needful, it will start. Till then we'll make sure that we engage everything properly. Now I am you can raise your hand. I'll unmute you. Was everything fine today? Any changes you want in the way I teach? You can raise your hand and tell me. Any doubt, anything that you want me. My English is not proper. uh, I'm going a bit fast. You didn't understand my writing. Anything that you want. See, we are not seeing each other. It's an online platform, so feedback is welcome. Please tell me. Very fine. It was good. Okay. So for today, I'll stop here. I'll close the lecture. And I needed to do a derivation, but I prefer that we'll start afresh next time. We'll finish the whole derivation, conversion of delta to star and star to delta. And I'll see you maybe tomorrow or day after tomorrow. Let's see. We'll also arrange lectures for mechanics and maths, and all three will go on. And we'll give you a detailed timetable as soon as possible. But we'll start engaging all three lectures every day now. Okay. Thank you. In case anybody has missed anything, this whole lecture is there live on YouTube. You can go back and see it. Thank you. You all can start logging out. Anybody needs to communicate with me regarding anything can unmute you. I will unmute you all and you can tell me. I have released the mute, so you can unmute yourself and ask me or tell me anything that you need to tell me. Today you will not have any more lecture. Today You will not have any more lecture. That's it. Yes, all the students of first year have same subjects. One more thing, because you were free and we were free, we have started engaging you lectures. As soon as more students join through cap round, we'll have a formal orientation for all of you. We'll have a formal orientation for all of you. Uh, this is something like a soft launch where we wanted that you start studying, and we will start teaching you. So anything that you want to know, you can put here and ask me. Yes, all branches have the same subjects in the first year. Yes.
Sir, I wanted to ask, after the payment of fees, where am I
Please,
supposed?
anything related to fees, admission, you have the number. This platform is only for teaching learning.
Okay,
Okay,
sir. Yes,
this platform is only for teaching learning. Okay, any doubt regarding what I taught you, you can ask me, or any feedback that you want to give me, you can put. But as far as admissions is concerned, you have those helpline numbers, you can call. So students, can I disconnect? Can I leave? Thank you very much for listening to me. I think this would be your first lecture after a very, very long time. You all were very nice, attentive, and be the same. Thank you. Thank you, everyone.